Right, today's Monday, May 11, 2020. We're moving on in our unit of gases, and today we will be able to explain Gay-Lussac's law through the egg bottle experiment, and then further on your own later, also be able to explain the gas laws. So we're going to do a starter. We'll do a question of our day to get our brains warmed up, and then we're going to move on with one of our gas laws, and our scientist, his name is Gay-Lussac, and we're going to see what he discovered, and we're going to do that through an egg bottle experiment. Your assignment for this lesson is going to be to read and summarize the gas law handout. Okay. So, our starter. I want our starter to be quick, quick and right to the point. So we have a picture here of two rams. For this image, I want you to explain what would happen to their positions if A. So here's the first scenario. The ram on the left was stronger than the right. And then B, the second scenario, both rams are equally strong. Okay. Whoa. So if you can write your answers here, either on your notebook, either to yourself, or you can write it in the chat, feel free to do so. Explain what would happen to their positions if the ram on the left was stronger than the right, and both rams are equally strong. I hope this is very obvious. So I'll give you about 20 more seconds. Either write it down, think to yourself, or write it in our Discord chat. So I'm seeing that Anthony is writing something, so I actually want to see what he's writing.
The ram on the left will push the one on the right farther to the right.
Cool. Nice. So Anthony wrote it down, and then Noe also said exactly the same thing. I know a lot of these starter questions may not seem obvious to you why I'm asking them, but hopefully as we move forward, it'll make sense. So the first example, it should be, these are no trick questions. That's why I try to give you some relatable, I don't know if it's relatable, but something easily non-chemistry related. So the ram on the left, if it is stronger, it's just going to push the weaker ram to the right, further back. Great. And then both of you also said for B, if they are equally strong, they're not going to be moving too much out of position. And then I actually like Anthony's words here. They're equally pushing with the same force. Okay, so keep these things in mind, right? Now, let's go on to our question of the day. I want you to state what is happening below. What is happening below? Whoops, sorry. Let me also put this in here. State what is happening in the picture. Let's take 20 seconds. Shout out. What is happening in this image? It's kind of like the dancer from last week. Say the first thing that comes to your mind. Gotta get our brains warmed up today. Okay. I want to get more answers. Okay. Oh. Let's do 50 more seconds. I think Jacqueline was trying to write something. Dots seem to be moving up and down. And then 10 more seconds for any last people. All right, cool. So there's actually many answers to this. My intent is that you say the first thing that comes to your mind, because you'll realize that people's perspectives are very different. And if you see in our Discord chat, we actually have four different answers. Okay, so I want you to try visualizing this. So try to force your brain to visualize that these dots, I think Jacqueline said this one, that the dots are moving up and down. So that's pretty cool. To me, this is the first thing I see. I see them moving up and down. Why my brain tells me that, I'm not really sure. The next one, if you think about it, you can change your perspective as not moving up and down, but really moving left to right. So I think this was one of the options not one of us said. This one's really cool. Eric, maybe from the dancer image last class, has this idea. It's moving clockwise. So kind of the dot, if you follow it, is top left, bottom right, bottom left, and then keeps repeating. Then Noe also said the same thing, moving in a circle. And he didn't really tell us which way, but maybe it's moving counterclockwise. And I also like, Anthony said that they were moving clockwise. And then Eric says, actually, they're just appearing and disappearing. So kind of interesting what type of, how you can have different perspectives and kind of force your brain if you really put your mind to it. So just kind of a little warm up for our brain today. All right, so let's move on to Unit 11, and we're moving more on gases. And today we're going to talk about Gay-Lussac's law. I know it sounds, he has a weird sounding name, but he's from France. This is his name. Okay. So last week in our simulations, I saw that a lot of you did that and turned it in, so thank you for doing so. We saw how gases behave according to 4 different factors: pressure, volume, amount, and temperature. Okay. If you need a summary, I actually added a slide. So whenever you get a chance, just click this and it'll go directly to our previous slides, okay? And I'd like to go over this summary today. It might still not be understandable now, but the more that you see it and hear it throughout this unit, it'll just stick eventually, okay? So one of these things in our simulation is when we kept the box the same, and when we keep the size the same, the volume is constant. We saw that as we increase the temperature, pressure also increases. Okay, so notice how they both are the same direction. If one increases, the other increases. I could have also written it the other way. If temperature decreases, pressure decreases, but I don't want to write too much because I only need to say it once in one way. If I change the amount that I have and it increases, the pressure also increases. And you can just visualize that right now. If there are more particles in that box, it makes sense that they're going to collide more and the pressure on the box increases as well. There was another scenario when we kept the temperature the same. If volume increases, the pressure decreases. So again, imagine, visualize. If my box gets much, much bigger, there's less chance for those particles to collide, and therefore the pressure decreases. So this is opposite. If one increases, the pressure decreases. And then last but not least, at constant pressure, as temperature increases, the volume increases. So notice how they're both the same. If I increase the amount, the volume increases. Again, the same. But now if I compare two different things, amount and temperature, if the amount increases, temperature decreases. So again, it's quite a lot, but as we go through, it'll make sense. And today we're going to focus on one of them, which is temperature and pressure. Okay. Oops, went too far. So today we're going to take a closer look at the relationship between temperature and pressure, known as Gay-Lussac's law. And we're going to do this through an egg bottle experiment. The handout is on Google Classroom. I'm going to give you all 30 seconds to bring that up, or at least get a chance to look at it, because that's what we are going to do today together. So if you want to do it with us together, feel free to do so. If you want to try doing it on your own at home, you can also do that. Okay. So, Gay-Lussac's law, temperature and pressure. This is called the egg bottle experiment. Okay, so first I want to show you where it is. So if you go to our Google Classroom page over here, and then click this document, because we're going to do this right now. And basically I copied and pasted this to the slides. So feel free to write on this. Or if you're just at home with a notebook, you can write also on your paper. And I'll just use a little paint in my pen pad here. So I'm going to show the video in just a moment. So this is obtaining evidence. What do we see? What can we, before we do the experiment? And there's 3 steps. I want you to draw the setup of the experiment, the before. As I show you the setup of this experiment, I want you to predict what will happen. Put that in the prediction box. And then later, I'll show you and finish the video, draw what happens, and that goes into the after box. So before, your prediction, and after. Okay, so let's see this video first. I think it's still uploading on YouTube, so I'll play this on my computer directly. Hi everyone, it's Mr. Dave. Let me put the volume up. All right, so let's go. I did this morning. It again with another experiment. This is called the egg bottle experiment because we have an egg and a bottle. Of course, we've been learning gases, so this experiment is going to showcase one of our gas laws, specifically by one scientist, Gay-Lussac. He showed the relationship between pressure and temperature, so I'd like to show you this experiment. For us to control temperature, we need something that's hot, so we have a flame, and then something that's going to be flammable. But before I do any of that, we have just a regular egg, hard boiled, so I cooked it. It's not raw, and then I just want you to see that it is resting regularly on the bottle. I can try putting some pressure onto it, but if you look very carefully here, it'll start to squish, and if I keep forcing this, it will just like break, and that's going to defeat the purpose of this. Also, I want to leave this here with me not touching it, because also just the weight of gravity is not enough to push it through the bottle. Okay, so let's get started. All right, so if you're with me and you have something to write with, we're going to draw our setup. So this is our before. Let me get my tablet out. All right, so this is our before. So we are going to draw a bottle. This is not going to be the best bottle drawing, but it's the best I could do on a computer. And then this is our egg. Okay. Also, we're going to put, I didn't show it in the video yet, but we're going to put a piece of paper here, and this is going to be on fire. Okay, so I'd like you to draw this in your box there. So this is your before, right? I'm going to give you about a minute, or no, maybe 45 seconds right now. I want you to predict what is going to happen. So what I'm going to do in this video, I'm going to light a piece of paper on fire, put it into the bottle, and then I will put the egg on top. Right? So I want you to write a prediction. What is going to happen? And maybe if you do not want to draw, you can write it in our Discord chat as well. What is your prediction about what might happen? Okay, go. So either draw it, write it, type it in chat. What do you predict will happen? So we have one prediction from Benjamin. Let's go 30 more seconds. I know it's hard that you're all at home, mics are off, and so on and so forth, but the more that we participate, whether you talk or whether you type, the quicker we can go along and more efficient we can go. We got 2 more people. Noe says the egg is going to fall in. Cool. Might fall off. Perfect. 10 more seconds. We have a couple more. We have a lot more, actually. cool. Crew says the fire will go out because it'll use up all the oxygen in the bottle. Okay. Ooh, lots of people are typing now. Going to fall in. And 2 more are typing, and then I'll wait. Fire will go out. Pressure will build up in the bottle, and the egg will get sucked in by the high pressure inside. Okay, so even more detail. I think I'll wait on Jacqueline. She's writing one more thing. Then I was thinking the fire will go out as well. Alright, so prediction. Alright, let's see it. The bottle. Okay. You know, the weight of gravity is not enough to push it through the bottle. Okay, so let's get started. Here I just need something that's flammable so that I can get the inside hot. And not touching anything, it is all the way down. Cool. Alright, cool. So, a lot of things. Let's go through our predictions. Egg falls in, might fall off. I like falling off because, hey, it's windy. It could push it off. Fire will go out. Fire indeed goes out. You can see the smoke. Pressure will build up in the bottle and the egg will get sucked in by the high pressure inside. So adding more detail. I will tell you, though, that it's pressure does not build up in the bottle, and I'll explain in just a moment. And then fire goes out. Cool. We have good predictions here. So, if you're following along, let's complete that third box. Here's the after. So, kind of reporting what we see. We're gathering and obtaining our evidence. So, here's our bottle. We have the egg inside, and then if whatever this one. Cool. Egg falls in. Okay. All right, cool. All right, let's build some claims. All right, so if you're following on the handout, this is the first thing I want you to do. Draw and describe the particles when the matches are lit. So that's the first scenario, that's our before. And then I want you to draw and describe the particles when the flame is gone. So this is what the handout looks like. You can write this in chat as well. Draw and describe, or maybe just describe, the temperature, movement, and pressure of the gas particles when the matches are lit. And then the scenario when the flame is gone. We talked a lot about particles and how they move last chapter as solids, liquids, and gases. So take a minute, describe the temperature, the movement, and pressure when the matches are lit or the paper is lit, and then when the flame is gone. So describe the temperature, movement, pressure of the gas particles. So there's 3 things to describe. You can say, oh, the temperature is higher, the movement is blank, and you have an idea of pressure. The pressure is blank. All right, let's see what Cruz says. So, obviously, when the matches are lit, the temperature is higher. Okay. We learned previously that when the temperature is increased or higher, the movement of particles is also faster. And then if we combine this with our simulation last class, then that means the pressure is higher. Okay, cool. And then let's see what happens when the flame is gone. If we can get someone else, so it should make sense that everything is the opposite. I just need someone to record that for us so that everyone can see. Either with the voice, on the mic, or in chat. Then we have another one of us. When the flame is gone, it should make sense that the opposite happens. The temperature is lower. They move slower. And then the pressure is lower. Okay, so keep all of these things in mind. All right, let's move on. Building claims part 2. Okay, so this comes in where our starter. Okay, draw and describe the forces when they are equal and then not equal. So again, here's the part of the handout. On the left, draw what happens when they are equal, or describe what happens when the forces are not equal. And then again, the picture of our RAM. Let's do this really quick. Come on. 20 seconds. Let's get other people. I'll do my version visually while some of you write and type. Danny's about to finish writing. All right, so here's my visual and description. So on the left, when they are equal, Notice how I use arrows to show kind of force. I could have done left and right, but I figured, well, the bottle is, vertical. So it doesn't matter which way, but either way, if I go right and left, they're kind of equal size and length. So what is going to happen is that it cancels out. Okay, nothing is going to happen. On the right side, when they are not equal, again, I showed pictures using arrows, so the top is much bigger and wider and just larger size in general, and it just makes it seem just like the ram picture that this one forcing going down is much stronger than up. So overall, this is going to overpower it and kind of push it down. So you'll see here it will move down. I could have done the same thing horizontally, maybe a bigger one going to the right and a small one to the left. It's gonna overpower and move this all the way to the right. Okay. So if we go back to our original picture with our bottle, we have our egg here. The air that was inside is also the same air that's outside. So if you imagine where the air can go, it's trying to move out. It's trying to move down. I actually I think this was Eric saying it might fall out. Well, yeah, if there's a lot of air and wind outside, maybe it pushes it to the right. But you know what? There is actually it did not fall, so that means there's also air pushing it to the left as well as to the right, down and up. So if you notice all of these arrows are going to cancel out. And we notice that the egg does nothing. So that's kind of a preview of what I want you to know here. So giving reasoning, I want you to explain what happened using your drawings and explanation. So use those two ideas of temperature, movement, and pressure, and your drawing of force to explain very explicitly why the egg goes down. So a lot of you predicted the egg falls in. I need someone to write a complete sentence or 2 sentences. Convince me. Convince your brother or sister, your siblings at home who do not know any chemistry. You should be able to explain to them, if you were to do this at home, and show them how this works. Because you should do it at home. You should ask your parents and show them too. Explain. I'd like someone to share out, please, whether speaking or typing. And this is it for today, once we finish. Short and sweet. We got some people typing. And as that's happening, I'll try to draw this. And hopefully we come to the same conclusion. Okay, let's see. So, when the match went out, the pressure inside the bottle decreased, making the outside force that is pushing the egg stronger than the force pushing against the egg from the inside. And the stronger force overpowered the other, and the egg fell in. Perfect. Awesome. So, let's try to recap. So, this is Gay-Lussac's law of at work. The air was hot. So that's the whole point of me putting that match inside. It was hot. But once it goes out, the temperature decreases. That should make sense. It was hot. It goes out. Temperature obviously has to decrease. We look back to the beginning of our last unit when we talked about states of matter. Well, particles move based on temperature. So if the temperature slows down or is decreasing, our particles slow down. If they slow down, those particles collide into each other less, they collide into the walls less, and we call that pressure. So the pressure inside this bottle is much lower. Well, it's still trying to escape this bottle. So here it is. But this pressure is much lower. So the pressure that was outside, it's still the same, but it is now greatly larger, and it kind of overpowers it, and then the egg falls in. Nice. So it's really cool with Anthony. He had the opposite explanation when he predicted, and then was right on the money for what happens afterwards. Okay, so that is that. I do have a part 2 and part 3 to the video, so let's continue watching. I'm going to skip a little bit because we'll just watch the whole thing. Okay. So in terms of how it's happening, we will learn that in Gay-Lussac's law of gases is that when the pressure is increased, the temperature also increases, or oppositely, if the pressure decreases, the temperature also decreases. So what's happening in here is when the bottle with the lit piece of paper is very hot, once I cover the opening with an egg, there's no longer any oxygen able to come in here, so eventually the flame will go out. So going from something that is lit to something that is no longer lit, the temperature is decreasing, therefore the pressure also decreases. We've been learning time and again, air has a lot of pressure to it. So if we're making a scenario where the pressure outside is much greater than the pressure than the pressure inside, that difference is that the outside pressure will push the egg inside. So really, this is a cool way of creating a mini vacuum, and it kind of pulls the egg through because it has a lower pressure. So, egg bottle experiment. I'm going to continue this, but I know you are students in high school who are very curious, and I know that you all have the same question. What question do you all have? Shout out with your mic or type it down. Come on. What is the question you all have? Perfect. Cool. Bait. It's not a bait, but I know. How do you get the egg out? I want you all to think about everything we just covered about how I had the egg push in, and I want you to think about this. 30 seconds. I know you'll get it right on the money. How do I get the egg back out based on what we just learned? How do I get the egg that's inside the bottle to be, how do I get it out? Give you 30 seconds. Let's do it. You can either use simple concepts and explain those concepts, or maybe you tell me exactly what to do. So Jacqueline says, would you heat the bottom of the bottle? What's the idea behind that? Also, Eric, what's the concept behind that? And then we'll get to it. And then we will be done. Pretty excited for this response. So let's see. Decrease the force, keeping the egg inside the bottle. I guess that works because that would keep the egg inside if I wanted it to keep inside. Anthony says you would heat the bottle, which would create more pressure inside, and the force inside will be stronger than the force outside the bottle. Okay, so it's pretty much the opposite of what we just did, or just in reverse. And then Jacqueline says, similarly, heat inside the bottle would then increase, create more pressure, and then allow the egg to slip out. Let's see it. Hello again. So you might be wondering, how do we get the egg out? So of course we can just smash it, but I want to use some chemistry. It's actually the same chemistry. So imagine I want to push this egg out. That means we need our pressure inside to be greater than outside. So using the same law, if we increase the temperature inside, the pressure also will increase, pushing the egg out. So I've kind of forced it a little bit by doing this so that it gets stuck at the rim. So now it just needs a little push. So I have some boiling hot water, and hopefully soon the egg will just slowly rise up. So temperature inside is increasing, pressure is also increasing, so you can see that it's pushing egg out, and hopefully it doesn't push it all the way out, but the idea is there regardless. Maybe we can pulp it out a little bit, and simple as that. So backwards again. Cool. Great predictions, great explanations, and because I like you all too much, a last demo. So this is the last one. Third one, still egg and bottle. Awesome, and now let's do one last experiment. For those of you still maybe have doubts, and maybe it's something to do with gravity, I'll do the same thing, but I'll do upside down. So this way I'll put the matches on the egg this time. Same thing. in reverse or upside down. That's all. Cool. So hopefully you got to see some interesting experiments with an egg in a bottle. You can try doing this at home, but please make sure you ask, your guardians to supervise you because you are playing with fire. The thing is, if you want to do this, you need a hard-boiled egg, and then you kind of need like the perfect bottle size so that it's not too big, of course, that it just, of course, falls in, but also not too small, because an egg isn't, it's not that, I guess, squishy. Okay. If you do end up using something too small, it'll actually shred your egg, but maybe that is something that you want to see. Okay. So a summary. Gay-Lussac was a French scientist who studied the relationship between temperature and pressure in the behavior of gases. He discovered that, and we also discovered that, as pressure increases, temperature also increases. So notice how they're both the same. And I could also say it the other way, because it's also the same. As pressure decreases, temperature also decreases. We have a very specific word for this. It's not a fancy word, but we have a specific word to describe this relationship. We call this a direct relationship. When one factor, such as pressure, affects another factor in the same way. As pressure increases, temperature also increases. Okay. We actually did this earlier in the year when we talked about hypotheses and variables. We could say something like, if I study more, my grades increase. Maybe that's a direct relationship. Maybe if I spend more time exercising, then my muscles increase. So notice how they're both a direct relationship. Something that would be opposite would be something like, if I increase the amount of video games that I play, then my grades will decrease. That would be called an indirect relationship, and that's something we'll see also as one of the gas laws next time. Okay, so we are done. I will upload this video in just a moment. There's some more demos if you'd like to see them on YouTube from the Sci Guys. They do their version of the egg bottle. It's no different than mine. You'll see another demo with a candle. A candle one is pretty cool. You can also do that at home. The video that I just did is also here. And then more practice on Google Classroom on gas laws. Your assignment is to read and summarize this gas law handout. Very easy, very quick, but I need you to learn all about the other ones, okay? There's actually 4 laws. So on first 2 pages, it seems like a lot, but it's really spaced out. Here's the one we did today, Gay-Lussac. And you're going to learn about 3 other scientists and the other things they learned. Here's Boyle's law, one from Charles, and then our boy Avogadro. Remember, we learned about that guy. He talked about the mole, and the mole tells us something about the amount. So Avogadro comes into play again. This is the second time we see him. Okay, and then all you need to do is summarize what you read and fill out this little handout. Basically, you're saying, is it direct or indirect? You're telling me what are the 2 factors that scientists talked about, and then you give me an example. So if we do Gay-Lussac's law, what we just did, we would say this law shows the direct, circle that one, relationship between temperature and pressure. So for example, as the temperature increases, the pressure increases. Okay, so notice how they're all the same. Okay, that is it for today.